Remember what I said earlier? Activities F, G, and H are considered a single node, right? Because they end in exact same location. And therefore, aside from F, we also have G, which ends at the same node. And finally, we also have H, which ends at the same node. But where does G start? Well, G starts where B ends. Now, as you can see in our network diagram, this is activity B, right? So this is node 1 is the starting point of activity B, and node 3 is the ending point of activity B. Now, since this is where activity B ends, so this is where activity G starts. So this is where our activity G will be located. Okay, so this is G or activity G. And as you can notice, activity G has a duration of 4 weeks. Okay, you have there 4 weeks. Our next activity is activity H. And as mentioned earlier, H also ends in the same node. However, it starts where C and D ends. Now, as you can notice in our network diagram, this is activity C and this is activity D. And as you can see, our activity C and D ends at node number 4. Now, since it says that our activity H starts where C and D end, so this is where the starting point of our activity H. Okay, this is how it is drawn in the network. Okay, so this is activity H. And as you can see in our tabulation, activity H has a duration of 7 weeks. Okay, you have there 7 weeks. Finally, we are done with activities F, G, and H respectively. So let's move on to our next activity, which is activity I. Again, like what we did earlier, we need to see to it whether activity I is an immediate predecessor of any other activities. As you can see, okay, if we try to go down right here, as you can see, yes, it is. I is an immediate predecessor for activity M, right? And it is an independent activity. And take note that I starts, okay? So I starts where C and D ends. As you can see in our network diagram, take note that I starts where C and D ends. Again, this is C, okay, this is C, and this is D, right? So the starting point of activity C is 1 or node 1, and the ending point is node 4. And for activity D, the starting point is 3, and the ending point is 4, correct? Now, since our activity I starts where C and D ends, therefore, this is where the starting point of our activity I. And remember, our activity I is an independent activity. So if we try to draw our activity I, this is how it would look like. Okay, there. And this becomes now our node number 7. Okay, so this is activity I. Our activity I has a duration of 3 weeks. Okay, we have 3 weeks. And finally, we are finally done with activity J and moving on to our activity K. And take note, like I said earlier, we need to see to it if activity K is an immediate predecessor of any other activity. Now, as you can see, a little lower, yes, it is. Our activity K is an immediate predecessor of activity N, and clearly it is not an independent activity activity because K ends with other activity, which is activity J. And take note as well that your K, okay, your K starts where F, G, and H ends. Now, as you can see in our network diagram, this is our activity F, this is our activity G, and this is our activity H respectively. And like I said earlier, our activity K starts where F, G, and H ends. Now, as you can notice, since node 6 is the ending point of activities F, G, and H, therefore, this is where we will start with our activity K. And like I said earlier, activity K is not an independent variable because it ends together with any other activity, which is activity J. And so for that matter, this is where our activity K is located. Okay, this is activity K. And as you can see in our tabulation, activity K has a duration of 5 weeks. Okay, you have there 5 weeks. No. Finally, we are done with activity K and let's move on to the next activity, which is activity L. And again, like I said earlier, we need to see to it if activity L is an immediate predecessor of any other activity. Now, as you can see a little below, no, it is not, okay? Now, that being said, L is an independent activity, but take note that L starts where F, G, and H ends. Now, as you can see in our network diagram, this is our activity F, this is our activity G, and this is our activity H. And as you can notice, node 6 is the ending point of activities F, G, and H. And so for that matter, remember that our activity L starts where F, G, and H end. So this is where our activity L starts. Okay, this becomes now our node number 9, and this is activity L. And as you can see in our tabulation, activity L has a duration of 4 weeks. So you have there 4 weeks. Finally, we are done with activity L and let's move on to our next activity. We have activity M. And like I said earlier, we need to see to it if M is an immediate predecessor of any other activity. Now, as you can see a little below, it is not, okay? Now, that being said, M is an independent activity and it starts where I ends. Now, as you can see in our network diagram, this is our activity I. Node 4 is the starting point of activity I and node 7 is the ending point of activity I. And remember, like I said earlier, our activity M starts where I ends. Now, since this is the ending point of activity I, this is where we will start with our activity M. So if we draw our network diagram, this is where M is located. Okay, this is activity M. And as you can see in our tabulation, M has a duration of 13 weeks. Okay, you have there 13 weeks. Finally, we are now done with activity M and right now we are now down to our last activity, which is activity N. And as you can notice, activity N is already our last activity and clearly this is not an immediate predecessor of any activities. So as you can notice, it starts where J and K ends. Now, as you can see in our network, that is our activity J, and this is where our activity K. And both of these activities, the ending point is node number 8, and therefore, this is where our activity N starts. So this is how it is being drawn. Okay, this is our last activity N. And as you can see in our tabulation, activity N has a duration of 9 weeks. Okay, you have 9 weeks. As you can see on our last three activities, activities L, M, and N respectively, these activities are not immediate predecessors for any other activity. So that is why we call these activities as our ending activities. This means that these activities end in the same node, which is node number 9. Now that we have finally completed the construction of our network diagram, the next thing that we need to do is to determine the critical path and project completion time. So what is meant by critical path then? If we say critical path, it is in project management, it refers to the longest path in the project network, which must be completed on time for the project to be finished on its due date. Now, it can be identified by listing all of the possible paths from the beginning node to the ending node of the project. And after having selected all the possible paths, the final step that we need to do is to select the path with the maximum sum of activity times on that path. As you can see on our network diagram, our starting node is node 1 and our ending node is node number 9, correct? Now what we need to do is to find all the possible paths that start from node 1 and ends to node 9. Now in this case, we have 1, 3, 6, 9. Okay. We also have 1, 4, 7, 9. We also have 1, 4, 6, 9. We also have 1, 4. We have 6, 8, and 9. We also have 1, 3, 6, 8, and 9. We have 1, 2, 5, 8, 9. We have 1, 3, 4, 6, 8, 9, and so on and so forth, correct? Now, these paths are possible paths that start from node 1 and end with node number 9. Now, with this, our main goal is to actually find which path is the maximum duration. Now, when I say which path is the maximum duration, what I mean about this is that which path is the critical path. Now, in order to do this, we need to strictly follow certain rules. Now, there are 4 phases in identifying the critical path. Now, the first rule or the first phase, utilize the project network and activity time estimates to identify the earliest start and the earliest finish time for each activity by making a forward pass through the network. So the next phase in identifying our critical path, that would be utilize the project completion time established in phase number 1 as the latest finish time for the last activity and make a backward pass through the network to determine the latest start and the total time required to complete the project. And third, we need to utilize the difference between the latest start or the latest start time and the earliest start time for each activity to identify the slack time for the activity. And finally, we need to find the activity with 0 slack. And these are our critical path activities. Okay, as you can see in our network diagram, for each node, we have 2 squares, right? For example, for node number 1, we have an upper square and a lower square. Now, please take note that for the lower square, that serves as our earliest start time. And for the upper square, that serves as our late completion time. Okay? Now, take note that our goal here is to actually find the earliest start time and the latest completion time for each and every node. Now, as you can see, it shows the formula in getting the earliest start time here. Now, this is the formula used in determining the earliest start time. Now, our formula is earliest start time of ending activity equals to the maximum of earliest start time of starting activity plus the duration. Now, where ES refers to our earliest start time, I refers to our starting activity, and J refers to our ending activity. And so for that matter, I'm gonna show you how this formula is being applied in our problem. Now, going back to our network diagram, take note that the earliest start time of the first node is always 0. So that means to say we will indicate 0 right here. Going back to our formula, take note that in getting the earliest start time, that would be equals to the maximum of the earliest start time of the starting activity plus the duration. Now, going back to our network diagram, take note that our earliest start for our node number 1, that would be 0. Now, moving on to our node number 2. Okay, now since the formula in getting the earliest start time, that would be the earliest start time of the starting activity plus the duration. So therefore, 0 plus 3, that would be 3. For node number 3, that would be the same process. The earliest start time of the starting node plus the duration. So in this case, the earliest start time of the node 1 is 0 plus the duration of 6. Therefore, our earliest start time for node number 3, that would be 6. And for node number 4, take note that there are two options involved, right? Now you have there nodes 1 to 4, and you also have nodes 3 to 4. Now, since there are two activities heading to node 4, we have activity C and activity D respectively. Now, how are we gonna go about this? Well, since we are doing the forward pass, we need to find the maximum value. Okay, as shown in our formula, we need to find the maximum value. Alright, so in this case, for activity C, its earliest start time is 0, okay, as you can see there, and its duration is 5. So 0 plus 5, that would be 5. And for node number 3, its earliest start time is 6, plus duration is 6. So therefore, the sum is 12. So which is maximum, 5 or 12? So clearly that is 12. And therefore, the earliest start time for our node number 4, that would be 12. And for node number 5, same process, okay? Earliest start time of the starting node plus the duration. So in this case, the earliest start time for node number 2, that would be 3, as you can see, plus the duration of 8. So 3 plus 8, that would be 11. And for node number 6, take note that there are two activities involved, right? You have activity G and activity H, respectively. Now, again, we need to find the maximum value. So, in this case, the earliest start for node number 3, that's 6, plus the duration of 4, that would be 10. And for activity H, the earliest start time for activity 4, that would be 12, plus the duration of 7, so that would be 19. So maximum is 19, and therefore that would be the earliest start time for our node number 6. And for node number 7, same process, that would be the earliest start time of the starting activity plus the duration. So in this case, you have 12 plus the duration of 3. Therefore, our earliest start time for node number 7, that would be 15. And for node number 8, take note that there are two activities involved. You have activity J and activity K respectively. Now, let's find the maximum value. So in case of activity J, the earliest start time, that's 11, plus duration of 6, that's 17. For node number 6, or for activity K rather, the earliest start is 19 plus 5 duration, so that would be 24. So maximum is 24. So that will be the amount that we will be inputting right here. And finally, for node number 9, take note that there are three activities involved. You have activity N, activity L, and activity M respectively. So we have to find again the maximum value. So in case of node number 8, your earliest start is 24 plus 9, so that would be 33. For node number 6, your earliest start time is 19 plus duration of 4, so that would be 23. And for node number 7, your earliest start is 15 plus duration of 13, that would be 28. So maximum is 33. And therefore, that will be the earliest start time for node number 9. Now that we have finally calculated the starting or the earliest start time for each and every node, at this point of time, the next thing that we need to do is to calculate the latest completion time of each node. Now take note that when we did the earliest start time calculation, we actually applied the forward pass, meaning to say we started from the starting node, which is node number 1, up until the ending node, which is node number 9. Now in this case, in calculating the latest completion time, we will be applying the backward pass, meaning we will start from node number 9, or the ending node, going back to node number 1, which is the starting node. So we will start from node 9, and take note that for the last node, the latest completion time should always be equal to the earliest time of the starting node. So how do we calculate then the latest completion time? Now, as you can see, this is the formula that is used in determining the latest completion time. So our formula that would be the latest completion time of starting activity equals to the minimum of the latest completion time of the ending activity minus its duration, where LC refers to latest completion, J refers to the ending activity, and I refers to the starting activity. And so for that matter, I'm gonna be showing you now how this formula is being applied in our problem. Now, in calculating the latest completion time, we will be applying the backward pass. And so for that matter, we will start with the ending node, which is node number 9. And take note that the latest completion time of the node would always be equal to the earliest starting time of the last node. So in this case, our latest completion time for node number 9, that would be 33. Now for node number 8, as you can notice, okay, right here, 33 is the latest completion time of the ending activity minus the duration of 9. And so for that matter, 33 minus 9, so that would be equal to 24. Okay, so for our latest completion time for node number 8, that would be 24. And for node number 7, okay, right here, for node number 7, as you can see, 33 is the latest completion time of the ending activity minus the duration of 13. And so for that matter, 33 minus 13, that would be 20. So 20 is the latest completion time of node number 7. And in node number 6, as you can notice, there are two activities involved, or there are two options, right? We have 9-6 and we also have 8-6, correct? Now, how are we gonna go about this? Well, since we are doing the backward pass, we need to find the minimum value. Again, based on our formula, as you can see, we need to find the minimum value. So as you can see, you have their latest completion time of 33 minus 4, so that would be 29. And for node number 8, you have their 24 latest completion time minus the duration of 5, which is 19. So which is the minimum value? 19 or 29? So 19 is the minimum value. And so for that matter, 19 will be our latest completion time for node number 6. And for node number 5, as you can see, you have there the latest completion time for node number 8 is 24 minus 6. So therefore, 24 minus 6. So your latest completion time for node number 5, that would be 18. Okay, so 18 is our latest completion time for node number 5. And for node number 4, as you can see, there are two activities involved. You have 7-4 and you also have 6-4. And again, like I said earlier, we need to find or enter the minimum value. So in this case, for node number 7, your latest completion time is 20 minus 3, so that would be 17. And for node number 6, your latest completion time is 19 minus 7, so that would be 12. And so for that matter, the minimum value is 12. So that will be our latest completion time for node number 4. And for node number 3, as you can notice, you have there 12 latest completion time for node number 4 minus 6. So the latest completion time for our activity 3, that would be 6. Okay? And for node number 2, so you have there latest completion time 18 minus 8, so that would be 10. And finally, for node number 1, as you can notice, there are 3 activities involved. So you have there 2, 1, 3, 1, and 4, 1. So like I said earlier, we need to find the minimum value. So in the case of node number 2, your latest completion time is 10 minus the duration of 3, that would be 7. And for node number 3, latest completion time is 6 minus 6, that would be 0. And for node number 4, latest completion time is 12 minus 5, so that would be 7. So meaning to say, since the least value is 0, so that would be the value that we will be entering right here. Okay? Now that we have finally calculated the earliest start time and the latest completion time for each and every activity, the next thing that we need to do is to find the critical path. So how do we do that? Well, in order to find the critical path, we have to consider 3 conditions. Now, in order for us to determine the critical path, the following 3 conditions must be satisfied. So the first condition says the earliest start time of the starting activity should be equal to the latest completion time of the starting activity. Now going back to our network diagram, as you can notice, the earliest start time of our starting activity is equal to the latest completion time of our starting activity. So our earliest start time of starting activity is 0, which is equal to the latest completion time of our starting activity. So in this case, our condition number 1 is being satisfied. Next, we have condition number 2, and our condition number 2 says the earliest start time of the ending activity should be equal to the latest completion time of the ending activity. Going back to our network diagram, as you can notice, node 1 is our starting activity, right? And node 3 is our ending activity. Now, In order for us to determine if our second condition is satisfied, now it says that the earliest start time of the ending activity should be equal to the latest completion time of the ending activity as well. So as you can notice, the earliest start time of our ending activity is 6, and the latest completion time of our ending activity is also 6. So they are equal, and therefore our second condition is being satisfied. And finally, the last condition should be the earliest start time of the ending activity minus the earliest start time of the starting activity should be equal to its duration. On the other hand, the latest completion time of the ending activity minus the latest completion time of the starting activity should also be equal to its duration. Now, going back to our network diagram, as you can notice, like I said earlier, your node 1 is the starting activity and node 3 is the ending activity. So, third condition says that your earliest start time of your ending activity minus the earliest start time of your starting activity. So, that would be 6 minus 0. So, that would be 6. And this should be equal to your duration. So in this case, your duration is 6. So 6 is equal to 6. On the other hand, the latest completion time of your ending activity should be minus the latest completion time of your starting activity. So 6 minus 0, that would be 6. And this should be equal to its duration. So 6, our duration is 6. So therefore, they are equal. And thus, the third condition is also being satisfied. Since our three conditions are being satisfied, we are now able to determine our critical path. So in this case, so our first critical path, that would be from node 1 to node 3. As you can see, they are equal, so 0, 0. So you also have 6, 6. So all we need to do is to highlight this. Okay, you have there. And also we have the fourth node, or node number 4. They are equal, 12, 12. So we need to highlight this one as well. And next we have node 6. We have 19, 19. So let's highlight this. And also we have node 8. You have 24, 24. So we will highlight this one. And finally, we have node 9. So we have 33, 33. So we will highlight this one. Okay, this will be our critical path. This is how our critical path would look like. So our critical path is 1, 3, 3, 4, 4, 6, 6, 8, 8, 9. So we will try to enter that one right here. So again, we have 1, 3. So we have 1, 1, 3, and then we have 4 and then 6. Okay, 1, 3, 4, 6, and then we have 8, 9. So we have 8, 9. So we will indicate which activities are these. So we have from 1 to 3, that's activity B. From 3 to 6, that's activity D. From 4 to 6, that's activity H. So you have H. From 6 to 8, you have activity K. So you have there K. And from 8 to 9, you have activity N. Okay, you have N. So that would be equal to, let's indicate the duration. So you have there from 1 to 3, you have 6 weeks. So you have there 6 plus, from 3 to 4, you have there 6 weeks. So plus 6 Okay, you have there plus 6. And from 4 to 6, you have 7. 6 to 8, you have 5. So plus 7 plus 5. And then finally, you have from 8 to 9, you have 9 weeks. Okay, so you have plus 9. So therefore, that would be a total of 33 weeks. So this will be our critical path. So this 33 weeks implies that this should be the longest path in, and so we can meet our deadline for our particular project that we are currently working on.